So we're going to get into today's show. As I mentioned before, we are going to do an episode where we look at community submissions that came about through our forum, which I'll share in a hot minute. And for that, I'm going to bring in one of my besties. Yeah, we have Paul Calvano in the building. Paul, how you doing?
I'm doing great. How are you?
Man, I'm not bad. I'm a little frazzled, so I have to apologize. It's too much going on here. I'm in a new location, new screen. Things are going just spazzo. But I'm always happy to see you, happy to chat with you, and happy that you can make some time and join us. Sergey says, I know this guy. Oh, speaking of, I don't know if you have an announcement to make. I don't know.
Yeah, Sergey. So Sergey runs the New York Web Performance Meetup, and he's been running it for 14 years. I think it was the very first performance meetup. And Sergey had asked me if I would be a co-organizer of it. And so both myself as well as Terry O'Shea from Etsy are going to be co-organizers of the New York Web Perf Meetup.
Awesome. That's fantastic news. We just broke some news, folks. Paul Calvano is going to join the good people over at the New York Web Perf Meetup. Man like Sergey, and yeah, it's going to be a lot of fun. That's awesome. And I know you have one coming up April 4th. I should have pulled it up. Maybe I will, or I'll talk about it. But hopefully we'll be able to get that over at the Etsy offices. Shout outs to Josh. Josh, I see you. Yeah, I have a coworker in the chat. I mentioned that I had Paul coming on, and he wanted to attend. So thank you for coming by, Josh. I do appreciate it. So Paul, what are we going to get into today?
So you shared a couple of URLs with me. I don't know if I can share my screen.
So as I mentioned, folks, last fall or sometime last summer, actually, we decided to sort of create this forum so that WebPageTest users could sort of, in your kind of day-to-day travels, looking at sites, you'd be able to sort of share some of these URLs if you found anything kind of interesting that you thought was kind of like, hey, this is kind of cool, or this is kind of wild, and you want to sort of share it with us so that we could talk about it on stream. And we're doing that. So today, for this episode, I brought Paul with me, and we're going to add to screen what he had found. So basically, we have the URLs, and we're able to sort of like scan them. And you send notes as well in terms of like what you thought you had seen that was kind of interesting, that piqued your interest. We'll look at it as well. We may find some other details that we thought were interesting, and it's really kind of like, again, this community collaboration that we like, and we want to talk about on stream. So that being said, what are we looking at, Paul?
So this came a submission from someone named Matthew. I don't know what his last name is, but said this was back in August. He wrote, we had just pushed a new version of, I don't know how to pronounce that website's name.
Yes.
Website. He said, I used all my knowledge in WebPerf on this one, and I'm wondering where we can go from here. And so, yeah, I ran a couple of web page test measurements, and I wanted to go through and see just looking at this particular homepage, what we can learn about its performance, maybe some of the techniques that that Matthew has done to optimize for it.
Yeah. And I remember Matthew out of France, because I remember looking at this form and I was like, oh, okay, cool. So he may not, well, it's not too late in his time, but all good. So what are we? What are the findings that we have?
So first thing that I noticed off the bat is that I've got some work to do because this site is fast. Like so looking at the real user metrics, it's blazing fast. Looking at the waterfall, it's very minimal. I wound up looking at, and so the submission actually came in on August 17th. So he said he just pushed a new version. And if we look at some of the historical metrics with Crux data, you can see that right around August, there was a massive improvement in performance. Largest contentful paint is almost half of what it was before. It looks like there was a little bump around October, but it's been holding steady. Looking at the other Crux data, it looks like most of the traffic for this website is coming from France. and it is split pretty evenly between desktop and mobile.
Oh, okay. Interesting.
So I wound up starting on desktop, and I also ran a mobile test as well. And so again, this very, very small number of requests, 700 kilobytes to load up. Pretty amazing. There was only one third party. This AMP-WIC, I think that was actually don't remember. I think it was an analytics call of sorts, like a Google Analytics replacement. But yeah, so it looks like we've got the base HTML, so the one CSS file, fonts, and then some images in JavaScript. Just kind of looking down the and we can actually go and look at some of the response headers here, and so they're gzip compressing their content. They're not caching their base HTML. Have HSTS enabled, so they were telling browsers to only arrive at HTTPS. Looks like they are preloading a CSS file. So that's this first CSS file here that gets preloaded very early on. The fonts are loading very quickly afterwards. And yeah, looking at some of the images, I can see that they were served with WebP. I wound up looking in DevTools to see like what the cache TTLs are. So it's easy enough to just kind of add a header here that says, sorry, I grab the content length header and just add the DevTools display, or the DevTools columns. So response headers, oh, content length is already there. Okay, never mind. Response headers, content length. Oh no, actually I was looking for the cache control. Where are you? There we go. So over here I can see the cache control headers are showing very long TTLs for the other resources. Now, one thing I noticed is that the domain name is not so Franz. This host name is not using a CDN. Okay. So we do a DNS lookup for that. It's what I was able to see is that it is being served from an ISP in France. So if most of the users are in France and the website's in France, the users are probably going to be getting a fast experience. Besides, if they branch out beyond just traffic in France, they're definitely going to want to use a CDN for that.
Nice.
Looking at some of the HTML response, I can see some pre-connects, DNS prefetches, preloads.
Yep.
It looks like they're doing a pre-connect and a DNS prefetch for the same domain name. They could probably just get rid of the DNS prefetch because the pre-connect is sufficient. Okay. And so I guess the reason why the fonts and some of those other requests were loading very early is because they were preloaded. Yeah. This was, I hadn't seen this one before, and if anyone in the chat has seen this or knows, I'm not aware of importance being a attribute for the link preload.
Importance attribute for a link preload. Interesting. And
was low because I don't think that importance being low is actually honored. It's certainly being loaded right away, and in the order of those preloads. But yeah, I thought that was interesting. I'm not sure where importance came from. So looking at the images, they're all being served with a version query parameter, which I thought was interesting. It probably doesn't matter if the version query parameter is not changing, but if it is, then that might produce a cache miss. So normally I would see like versioned assets for resources that are frequently being changed, but I think that might just be coincidence that's in there, since it's definitely loading from cache, and I'm seeing the same timestamp being included in the URLs on reloads.
Yeah. A couple comments here. Brian, I was going to call you Screenspan, Brian. So sorry. Wondering if it should be fetch priority. And then Adam also made a comment with regards to priority hints. But again, it's super interesting. And I don't think either answer here is wrong. We get back to the actual sort of testing. But, I digress.
So one thing that I like when I was the base HTML is dynamic. So there's a little bit of time to first byte here. There's the TCP and TLS time, and this request was coming from I think it was coming from Virginia. So this is kind of a worst case scenario because it was not being loaded from
France.
So yeah, I could probably rerun the test and test it from France. Actually, why don't I do that quick?
But and folks, very interesting case here because again, when this sort of request, I shouldn't say that. When the submission came in some time back, I remember when I did pick it up, he had mentioned like they had been working, diligently on trying to make things as fast as possible. So, the confirmation from Paul is certainly gratifying, but, we're going to do a quick little test to see what happens when we sort of, change geos and set it up in France because we can.
Alrighty. Well, that's running. Let's see. Let's take a look at some of the images. So these are being served via WebP. I was interested in seeing how the images are being requested. Back to the DevTools view, and we click on the initiator for an image. We could, it's actually not showing up, but there was a picture element. Yes. So this is another one where they're using lazy loading. Actually, they're using they're using loading equals eager for some of the images, and if we go all the way down and look at some of the other images that are being loaded, they're using loading equals lazy. So they're using loading equals lazy, but they're also specifically specifying that it should be eagerly loaded if it's within the viewport. So that's really good. A lot of times we'll see like when websites introduce the loading equals lazy attribute, some of them just include it for every URL. In this case, it looks like he's being very careful about making sure that he's only lazy loading things that are further down below.
Yeah, a mistake that's seems to creep up every so often.
Yep. And so they're using the picture elements, which is how they're serving the different image formats and so forth.
Interesting. Okay, so no CDN there. I mean, image management tool, anyways.
Yeah. There was, I did notice, I thought it was on the site, where I noticed a placeholder image that was being loaded.
Ooh, really?
I'm trying to see if I can find it. Yeah, here we go. So a lot of these images had the same placeholder image. And so this placeholder image, we could probably, let me see if I can go.
Did you all right? It's interesting because this may fall right into what I think he's in the audience as well. Yes, I think he is. Josh, is that you? Josh and I talked about this last week. How people are potentially loading these placeholders that, whoa, okay.
So, and it's not just a generic placeholder, it's a low quality placeholder.
Interesting. I mean, so I think we talked about this last week, but I know that there is a discussion with regards to, well, I shouldn't say that there's any problem with this placeholder because it probably isn't. It's a low quality placeholder. You want to make sure that something loaded up fairly quickly. I don't know what that looked like. It looked like food or something. Maybe it was.
I think it was the hero image.
Yeah. So, but that's even more interesting because I know that there's a bit of discussion with regards to what should be. Well, again, it's a hero image. I'm not going to assume it's the LCP, but there is a discussion as to whether or not um, low quality LCP candidates should actually be candidates for LCP. I mean, this is very nuanced discussion taking place around that conversation. And this is something that Josh and I talked about last week. Video could be out soon.
Yeah. Now sometimes when I see a low quality image being used, it's the image is loading via another image request first, and then it's being. What they're specifically doing is adding a low quality image in a data URI, so it's actually embedded in the HTML. Debug Bear's got this really great HTML analyzer where you can actually go and see where the HTML is actually being, where the size of the HTML actually comes from. You can actually look at this and see, the Piro image was reduced to 5 kilobytes in the HTML, less than 1 kilobyte for a lot of these other, images. And there's just a handful of them, right?
Yeah.
So the it really only amounted to an additional 8 kilobytes of uncompressed HTML. Percentage of total, it seems high, but it's such a small HTML payload that I don't think it's hurting them.
Yep. No, it's an interesting conversation that they're having. So we'll see what moves forward with regards to decisions around that space. Anything else on this site that you thought may have caught your eye before we maybe move to a second one?
No, I think we can move to the next one.
Yeah. The one thing I did want to mention with this one is I remember seeing so little, and as you mentioned in the beginning, very little JavaScript, it seemed, and you could tell from the pie chart, in fact, just even on a glance, I remember seeing like so little JavaScript, which is these days kind of like, oh, heartwarming, because we are into a very interesting space right now where you're actually seeing JavaScript payloads sort of that are larger than image payloads, which to me is just bizarro world. Anyhow,
here's the WebPageTest measurement from France, and it's like less than 0.8 seconds for page load, and
amazing,
consistent across all of the
tests,
which is pretty awesome.
That is fantastic. Did you want to scroll up real quick to the sort of like RUM section of the page? We actually just made an update to this section. Actually, I think it dropped either Monday or Tuesday, but it might have been Monday. The skillful Scott Gel over at WebPageTest just sort of like made some edits to this page. It looked a little different, and we just feel that this is a lot friendlier. It's a lot more sort of like it just kind of feels like a better user experience, just kind of looking at this data as laid out like this now. So I mean, a very quiet update, I'll just say.
Cool. Yeah, I love this. I love that it also shows there's maybe a couple of months ago or a year ago, this little indicator was added to the to the visual here. But I love that it specifically calls out exactly how the synthetic test compares to the real user experience.
Awesome. Yeah, let's look at a different another submission.
Yeah, so this is another one that we received. This one came from Luke Zander. He shared a WebPageTest URL, and he said that there's a high time to first byte on the first and third runs, but not on the second. This seems to have impacted all downstream metrics as well. Also, there's a lot of requests. So here's the WebPageTest measurement that he had shared. And you can see there's a very, very
wow,
5.5 seconds. And if we kind of scroll down, you can see that there's definitely a lot of requests. That is a very large number of CSS files. And then there's a lot of JavaScript. There's some images. There's a bunch of fonts. There's a little bit of everything here.
Yep.
a lot of API calls. If we look at this from the connection view, you can also see that the businessaviationlearning.cae.com site is where all the API requests and HTML is being loaded from.
Mm-hmm.
And they're using CAE exchange.vtx or vtexassets.com for delivering the embedded content.
Mm-hmm.
Now it looks like so it looks like the vtexassets.com domain is a hosted domain. So I think that's VTEX e-commerce platform that is serving this. If I look, you can see over here that they're using they're using AWS CloudFront to cache it, and you can see this is a cache hit as well. So this is being served from cache, and it looks like VTEX also must have an internal cache layer as well, because you can see kind of this hit from a cache server that they're exposing in the response headers. So it looks like there's multiple tiers of caching here, and then it's cached for a very long time at the edge, in the browser, and it's also immutable for the browsers that support immutable caching. So these are from a caching perspective. This looks really good. The business, this one here. So there's actually the cache control header for this one is interesting. So it's cache control public. There's a max age, and it's a really low max age. So this is telling the browser that it can cache it for 323 seconds.
Yep.
X max age is telling the CDN, which in this case is Cloudflare, that it can cache it for 60 seconds. Okay. So it is cacheable on the CDN. And then stale while we revalidate is also telling the CDN, or at least this one specific to Cloudflare. I think it was, I found it in their docs somewhere, where they actually said that if you add that header, then they will, where's it? Here we go. If you add that header, they will cache the, they will serve the content stale. So if you include that, they will serve the content stale from their cache. And that is also saying that, you know, if it's within, let's say a request comes in 70 seconds after my initial request. Okay? Make a request, someone else in the same location makes a request 70 seconds later. It's no longer in the CD. It's no longer considered a cache hit at the CDN. The CDN is going to deliver a cache hit while it revalidates it. But it's only going to do that for up to 600 seconds. Now, I wound up taking that test, and I ran 9 of them. I think this was the test I ran. No, this was the one. So I wound up running 9 tests just to kind of see. Let me go back to the performance summary. And so you can see that really long time to first byte on the first hit, and then the subsequent hits are very fast. So it does appear to be working, but that first hit is very, very slow. I think that there's something to be said for you know, increasing the cache TTL if it's the content is not as sensitive. But they should definitely look into what is causing that excessive time to first byte on the back end. I do have some thoughts about what it might be. And I can show you from actually where's the, so if we take a look at the HTML for this page, well, first of all, you can see that they're not doing preloads, but they've got all of the style sheets and that we saw in the that we saw in the web page test measurement here. But if so I tried taking this and running this through that HTML size analyzer. And so when I did this, I think it says it failed to load the URL, and I think it was good because it was too large. So
okay.
Go back here, and I just copy all of the HTML to my clipboard and run that test. So I'm just going to paste the HTML code into here. We can see that 1.6 meg HTML
Wow.
Massive HTML payload. 1.3 meg of this is one block of script, or 1.25 megabytes is just this runtime hydration.
Wow.
So that is accounting for 75, 80% of the HTML payload. And if this is cacheable, then whatever is generating this, if there's some caching tier that could be added in between that, or if it's something that is potentially able to be made static. I'm as familiar with optimization on rehydration, but I think there's definitely some tuning that I would look into doing here.
1.5 megabytes of HTML. I don't think I've ever seen that, or at least I don't believe so.
I think the HTTP archive might.
Yeah. I mean, like, I just don't think I've ever seen that with my own eyes. Wow.
And so you can see also on the historical REM data as well, like the 75th percentile is 3.8 seconds. That time
yeah, it's never been amazing. So, wow. I mean, what was it? Well, did we know? What was it? What was the 1.5? Well, the 1.6 megabytes. That's not compressed.
So yes, that was. So and you can see over here, like if I look at this request payload,
so it's still a meg.
Here was 1 meg, and compressed it was like 10 or 11% of that.
Yeah, still a meg though. Wow.
So there's not as much being delivered over the wire, but it's also a lot for the
initial
to parse.
Wow.
Yeah.
Wow. That's crazy.
Now, when I ran that test, by the way, I noticed. So, like, let's say I take one of these other tests where we didn't have that time to first byte issue. So here's a case where we've got the response cached. HTML returns very quickly from the CDN cache. You can see the third-party request. You could see the CSS requests start loading very quickly while that HTML payload is being delivered. And then there's definitely a lot of them. This here I thought was really interesting. So with HTTP2, all of these requests are being fired in parallel. But instead of delivering the response in chunks or one at a time, and you can kind of see this over here, like this was also using H2, but some of the requests kind of came in order. In this particular example, these requests seem to be kind of interleaved, where there wasn't any single piece of content that was being delivered fast. Everything was slowed down equally. And so this was on the CloudFront CDN, and I'm not 100% sure, but I think that this may be related to the H2 prioritization issues that Andy Davies had written about a few years ago. All of the, and you can kind of see the examples here that look very similar.
Yeah.
And he kind of broke out all the different CDNs that and how they were doing on H2 prioritization. And this is
and CloudFront wasn't part of it.
Yeah. So I think that might be the case. If I was hosting this content and I was using a CDN, I might look into seeing whether I could front that content with my CDN, right? So, for example, if he's using Cloudflare in order to deliver this content, he could potentially deliver he could deliver all of these resources from the same domain and just use Cloudflare to route the traffic to the right to the right origin, or even to the CloudFront host name. There was Chris Coyer had written a blog post about this 2 years ago, where he actually showed how to do this in Cloudflare workers.
Okay.
There's other ways to do this on other CDNs. Like I know with Akamai, you can make a behavior to do it. With Fastly, you can use VCL. But yeah, this was specific to Cloudflare, how to do this particular type of optimization using Cloudflare workers. So I think this example here might be helpful to trying to optimize that and just seeing like what would happen if this was to be delivered through a different CDN. Also running a WebPageTest experiment, I think that goes through Netlify.
Yes.
So you'd also be able to test those resources through a different CDN and just see how the requests load and whether the difference in prioritization is beneficial. Oh yeah. So there's one other thing I wanted. I know we only have a few minutes left.
Yeah.
I want to talk about this here. So this huge block of CSS files. Now, when you look at each of the CSS files, you'll notice that like some of these are like, this is a 20 kilobyte CSS file and it's being compressed to 4.4 kilobytes.
Yeah.
If we look at some of the other ones, here's 41 kilobytes compressed to 7.2 kilobytes. But then we've got like 4.4 kilobytes being compressed to 1. And 0.2 kilobytes being compressed
to 0.2
because there wasn't
nothing.
And some of these are like the browser was actually sending more bytes as
out
a request.
Yeah,
was receiving content.
I love seeing those because it's like, what?
I want to show you. So if I take one of these requests, I'm going to go and export the request CSV file. And I'm going to take that CSV file and I'm going to import it. Where's the import button? Is it, why is that not working? Refresh. Okay. Let's say new spreadsheet. There we go. So I'm going to import this CSV file, and we will have some data. I love these CSV files because every single request, all the different metrics. If you're someone that likes messing around with pivot tables, you can do some really cool stuff with this.
I know you stay with the pivot tables. I've seen you work with those.
But if I take a look at, let's just say, I'm just going to clear this just for my own purposes here. If I take a look at all of the different CSS requests that were in that first block of requests, and I sum the, is this the bytes? Yeah. If I sum the bytes for that, we're looking at about 83 kilobytes of data. So 83 kilobytes.
Over like about almost like 30 requests, I think it was. It was a bunch.
Yes. So I'm going to actually take that list of URLs, copy them, and we are going to go and those in a text file. That's not right. Hold on. Did something wrong. Live demo time. Great. I did this the other day and it worked. Or the other. So there's document URL. That's why, because I needed the actual URL. So I'm going to take the actual URL this time. And we're going to do that again. So okay. Now I want to do. I'm going to cat css.text just to verify that this is working. I'm just going to do an echo I. It should give me this should essentially output a list of all of the URLs. And so there we go. That's all the CSS files. What I want to do is I want to do a wget. For some reason, when I was trying this earlier, it did not like that I was. There's some issue with IPv6 on mine. I think it was just a me issue. So I'm just going to say inet4 only and do this. And what's going to happen here is it is downloading all of these files.
Okay.
So now I've got all of the CSS files that were downloaded by the browser over here. Right.
Mm-hmm.
And I'm going to do a cat star CSS, and I'm going to put that into all CSS dot text. So all CSS dot text is 446 kilobytes. So there's 446 kilobytes of CSS. There's probably a lot of unused CSS, so I'd also clean that up. But if I were to do a gzip -9 on all CSS dot text, it's 65 kilobytes. So
Wow.
20 kilobyte reduction on the bytes that were actually delivered. And then 36 times like 2 kilobytes for request headers. So I definitely would bundle these. I know that like there's always kind of should I bundle? Should I not bundle? But I think that in this case, I would bundle this, but then I would also use the unused CSS tool to in DevTools to figure out is how much of this is actually being used.
Yeah. So basically, we've had more weight in headers than we did in actual files after it was gzip properly.
Is that right?
Is that what I just heard? So because 72, and you said it came out to like 60 if you compress the file. So 72 out, 60 in. Is that what it was?
Yeah, I think so.
Yeah, something along those lines.
And if we look at CSS files here, you can see that these are really tiny CSS files, but some of them are some of them are 100% used, some of them are not. Some of them are like 71% or 63% and so forth.
Yeah, exactly.
I think that bundling this and then running this analysis to determine what CSS could be stripped out is probably one way of doing this. Yeah.
I mean, there's several ways out there to sort of like look into that. And Mr. Greenspan, I do believe so. I have to go back and double check. There's a lot in there, but I'll be able to confirm that. Brian. But that's awesome. Thank you very much for that. And again, things to think about when you're auditing. Folks, I've always said it before, and I'll say it again, it is a bit of an investigative process. There are things that you may not, figure out until you poke around, go through layers, click here, click there, and then you pick up what could be changed. And if you do that, 1,000 times over, or for 10,000 hours, like a famous Jamaican Canadian said, you'll turn into Paul Calvano, because that's how skilled you'll be after you put in your 10,000 hours. Paul, thank you very much.
Sure.
I do appreciate you jumping on, as usual, to show us a few things. Same things are counterintuitive too. Don't stop but blame yourself. There's probably an answer. Yeah. Yes, Sergey, you're absolutely correct. That said, I know you have to jump in a meeting, so I'm just going to wrap it up like this. Folks, thank you very much for joining us. As usual, oh man, I guess I'd have to go into the banners. Give us a follow. Oh, no, that's not the one. That's the one. If you're on Twitter, give us a follow. We're not on Mastodon yet over at WebPageTest, but we'll figure it out. I talked about the meetups. If you're interested in running a meetup, bit.ly/perf-meetups. Give us a little, let us know, fill out the form. It'll take 2 minutes. I'll get notified. If you're into this kind of show and you want to sort of do these submissions, submit a URL and have us take a look at it, let us know, bit.ly/WPT-submission. We'd be happy to take a look at them. And with that being said, thank you very much. Have yourself a pleasant day or rest of day. Paul, again, much appreciation for taking your time and showing us how an audit goes down. And with that being said, folks, what is going on here? I have a comment. Thank you, Brian. Thank you, Eric, for joining us. And with that being said, have yourself a great day, folks, and we will catch up to you very soon. Oh, last thing. Happy International Women's Day.